In this video, we are going to see about the two-port network. Generally, port is a pair of terminal at which the signal may ends or received from the network. So, in the two ports, we are having the two pair of terminal. Here it is a network. This is the input port. It is termed as 1 dash, and then it is termed as the output port 2 dash, and then the parameters are here it is the V1 input voltage, and then I1 is the input current, and then V2 and then I2 are the output voltage and then output current. So here we are having the two port networks, and then in the two port networks also we are having the two types, active port and then passive port. In the active port, if an energy source is connected in a network means in a port terminal means that will be termed as the active port, and then passive port means there is no energy sources connected. So here we are having the three two port network parameters, and then Z it is termed as the impedance, and then Y port it is termed as the admittance, and then H denotes the hybrid parameters. So now we are going to see how to derive the Z, Y and then H parameters. Initially we have to write the equation for the two port network. Here it is the equation for the two port network. V1 equal to Z11 into I1 plus Z12 into I2. Here the V1 equal to the Z11. Z11 is the impedance which is present in the only in the port 1, and then Z12 is the impedance present common between the port 1 and then port 2. Here Z11 depends upon the input current, and then Z12 depends upon the I2 current. And then second equation V2 equal to Z21 into I1 plus Z22 into I2. Z21 is the impedance which is present common between the both port 1 and then port 2, which depends upon the value of I1. And then Z22 is the impedance which is present only in the port 2, which depends upon the current I2. In the next step, we are going to frame the matrix. So this is the V equal to Z into I. So in the impedance matrix here we are having the 2 cross 2 matrix, because here we are having the 4 parameters, and then I1 and then I2. Next thing, in the first step we are going to open circuit the port. So to find the value of Z11 and then Z21, first we are going to open circuit the output terminal. Open circuited means the current will be 0, I2 equal to 0. So we are going to substitute the I2 equal to 0 value in the first and then second equation. If we substitute the value means here the whole term will be 0. Then the equation will be rewritten as V1 equal to Z11 into I1. So we can find the value of Z11. So Z11 equal to V1 by I1. Again, next step, we are going to substitute the same value I2 equal to 0 in the second equation. So the whole parameter will be, whole term will be termed as 0. So then the equation will be V2 equal to Z21 into I1. So V2 equal to Z21 into I1. Then we can rewrite the Z21 term equal to V2 by I2. And then in the first step, we identify the values for Z11 and then Z21. In the next step, we are going to open circuit the input terminal. So the current value will be 0, I1 equal to 0. Now we are going to substitute this value in the again in equation 1 and 2. So here we are going to substitute the I1 value as 0. Then we can easily find the value for Z12. And then we are going to substitute the same value in equation 2 also. Then we can easily find out the value of Z22. So here, after substituting the value of I1 equal to 0, the equation will become like this. Then Z12 equal to V1 by I2. And the second equation, it will be term like this, V2 equal to Z22 into I2. Then the Z22 value will be V2 by I2. So these are the Z parameters of the two-port network. Z11 equal to V1 by I1, which depends upon the voltage and current in the input ports. Z21 means which depends upon the voltage in the port 2 but current in the port 1. Z12 means which depends upon the voltage in the port 1 but the current in the port 2. And then Z22 means which depends upon the voltage and in current both in the port 2. So here this is the final equation we derived. Z11, Z12, Z21 and then Z22. These are the condition. First initially in the step 1 we make the output terminal as open circuited. The current value is 0. That is the value. I2 equal to 0. Here the input port is open circuited. The I1 equal to 0. The same thing will be repeated like this. Here we can term Z11 as the driving point and then Z12 will be termed as the transfer impedance and then Z22 will be termed as again the driving point and then Z12 will be termed as the transfer impedance. Now we are going to draw the equivalent circuit for this Z parameter. So this is the equivalent circuit for the Z parameter. Here we are having the Z11 impedance which is present in the port 1 and then Z22. This is for the output port. So Z22 impedance. These are the dependent voltage sources. Dependent voltage sources means here Z12 which depends upon the Z12 parameter. So Z12 into I2. Here we are writing the dependent voltage source as Z21 into I2 which depends upon the current value in the port 1. So we can tell the network is to be a reciprocal for Z12 equal to minus of Z21 and then for the symmetrical value Z11 equal to Z22. So this is the derivation for the Z parameters, impedance parameters. Likewise, we have to derive the equation for the admittance. So for the admittance, here we are writing the equation I1 equal to Y11 into V1 plus Y12 into V2 and then the second equation will be I2 equal to Y12 into V1 plus Y22 into V2 and then in the second step we are going to frame the matrix I1 and then I2 and then admittance matrix and then here it is V1 V2. Okay, and then in the first step we are going to short circuit but in the impedance circuit we open circuit the terminals. For the admittance we have to short circuit the terminal. In the step 1 we are going to short circuit the port 2. Short circuited means the voltage value will be 0. Here the V2 will be 0. So the same procedure will be repeated here also. So first condition is we are going to short circuit the output port. Short circuit the output port means V2 value will be 0. So here we are going to substitute the V2 equal to 0 in the first equation. Then we can, if we substitute the V2 value is 0 means we can find out the value for Y11. So I1 equal to Y11 into V1. So if we are rearranging this equation means Y11 equal to I1 by V1. In the second equation if we substitute the value V2 equal to 0 means I2 equal to Y21 into V1. So Y21 value will be I2 by V1 and then in the second case we are going to short circuit the input port. So the input port short circuited means V1 value will be 0. Now the condition will be substituted in the two equation. V1 value will be substituted as 0. So the equation will be I1 equal to 0 plus Y12 V2. So the Y12 equal to I1 by V2. And then in the second equation, if we substitute the value means I2 equal to Y22 into V2, then the admittance value will be I2 by V2. The same procedure will be repeated for the impedance. We substituted, for the impedance, we make that input port and then output port are open circuited. For the admittance, it will be short circuited. Based on that, we are substituting the value in the two equation and then we find out the parameter value. So after substituting all this value, so this will be the final admittance value, Y11 equal to I1 by V1. In this case, the output port is short circuited and then Y21 equal to I2 by V1. The same thing is written for remaining all the two terms. Here, the Y11 will be considered as the driving point admittance. And then Y21 will be considered as transfer admittance. And then Y12 is also considered as the transfer admittance. And then Y22 is the driving point admittance. Now we are going to draw the equivalent circuit for the admittance. Here, the value is based on the current value. So, here we are having the dependent current source both in the input and then output port. We are having the dependent current source. So current source means we will have the parallel resistance. So here we are having the admittance. Parallelly the admittance value is connected. It is a port 1. So here we are having the Y11 value. And then the current source depends upon the output voltage. So here it is written as Y12 into V1. The input voltage is V1 and then input current is I1. This is for output port. For the output port, the admittance value is Y21. It depends upon the voltage of the input port. So Y21 into V1. Here the parallel admittance value is connected. It is termed as Y22. For the output port, here we are having the voltage and then current value as V2 and then I2. And then the same Y12 and then 21 are the reciprocal values and then symmetrical values are Y11 and then Y22. Likewise, we have to identify the impedance and then admittance parameters. Thank you.